20 objects. Maybe I can reduce this a bit. Speed. The speed is so low. Well, I don't know if that's the reason. Because it's slow compiling too. Now, and I'm adding all those things to A here. Okay. And then calling foo of A, which is going to walk through all of A's elements and print out what's in there. One of the things that I'll show you in a minute. So I added a random string generator to my TS string class. And it takes a length and a character set. So this is upper and lowercase letters, stars and question marks, brackets, plus, minus, and so on. And this should be between 1 and 31, I guess. The 1 and 30. Okay, I think it's starting. Allocation is, so at worst 10, at worst 150,000 bytes. Filled with garbage, I dump out a random amount of bytes, add the object to our A, and pause. Now, I'm going to pause this. There we go. It started as soon as I pressed pause. So here's our string, and here's some of the data. Here's the next one. And it's not showing us the size, but it will when we get to the foo section, which prints out get and size, and the info, which I'm missing here too. Okay, there are 2 letters. Doing 20 of these. Do I have a breakpoint here? No, I should. Okay. So here's A. It has 20 elements. Here are the objects. Here's the first object. And they're all going to have 1 reference count. Okay. Next. One. They're all 1s. So now we step into foo here. Now we've made a copy of A. So all of these now are going to have, the whole list has been copied. So all of the members are going to have 2 reference counts. Okay, makes sense. Yeah, now that's so. There are 2 references. There's a reference being held by this copy of A, right? And A itself. This original stuff is long since disappeared. Okay. So here's the string is that. We probably saw it before. The size 135K. Info. Now info I chose to be a random positive or negative number. Testing out my fancy format base 10. Do you know how to do this quickly? It's so silly. It's almost comical. To do a format base 10, if you know the buffer size, okay, now this looks complicated because I'm passing a pointer to functions all this thing is like L to, long to ASCII, okay? But there's long longs and there's longs. There's long longs and longs. So one has a 64-bit thing, one's a 32-bit thing. So that creates a ASCII string that represents the number. The number, right? Now, all you do is you start at the end of the string, take the length of the string, that's the length of buff, minus 3, as long as I is bigger than 0. Now this I'm just taking into account the possibility of a minus sign. And you just keep subtracting 3. So subtract 3 and insert a comma. Then subtract 3 and insert a comma. And that's all there is to it. I've seen crazy algorithms where people are dividing by powers of 10 and trying to figure it out. But there's nothing to do, right? You just split and put a comma and then go back another 3. Anyway, it's never failed me yet. So here are our things. All those, 135K, 45K, the passing of all that data into food here didn't cost anything, right? All it did was increment a bunch of reference counts. Almost done. And we don't have any memory leaks or anything. Okay. Now the final word on this is smart. This smart pointer, which is what you do if you have something that's not one of these refs things. So the comment says sometimes you want a smart pointer something that's not a ref. In that case, we create a refs object for that data type. So for instance, byte or color ref or RGB triple or something. I have a class here, a template class called AutoRefPointer. So it derives from refs, okay, and has its member a T. Now T's got to be an aggregate type, like no constructors or destructors, anything, or else it's not going to work. Because the way you use this thing is by, well, new to create and delete to get rid of, and this is a scalar delete. So if you're creating an array of things with constructors and destructors, that's going to fail. You'd have to make another type of class. But this is good for things like bytes, car. So here's a byte star AutoRefPointer. So it has its member, and so it's just a class that looks like that ref PTR. In fact, it's very similar. Well, no, not really. What is it similar to? Nothing. It's a refs, okay? So whatever you can say about refs, you can say about it. Now, I just went through a long, difficult explanation of this object, and I really think that it's too long for me to go through the explanation. So I can scroll through this here, and you can pause, copy it all down, run through it on your own, and see if you can figure out how it works. And if you can't figure it out, then you can always send me a message and ask. Now, there's just one more vital thing to be mentioned, and then one other thing for fun. Okay. Some time to get used to it. I wanted to mention one other thing before going, which is that the destructor of your class, if you're doing it the simple way, either way, there's no destructor for a byte, but the destructor has to be private. Because the last thing we want someone to do, right, like here. See, I didn't even realize that I took that this was a pointer. The last thing we want someone to do is this. Right? Even if this is an HMY class, I can cast this to a my class star, and if I delete that, okay, then its reference count isn't going to go up or down. So I have to make sure that the destructor is private, so that the only class that is able to do the deleting goes through the smart pointer interface, which, ignoring this new bit, eventually does the deleting through refs. Okay? So that's the only way you want the delete to happen, so that everything balances properly. And try this. Let's say byte. So now I have to use new because this thing uses delete. Now for a byte, let's say 300 or something. You would think that normally when you do new and then object type and then number, right? Then to delete the array, you're supposed to use what they call the vector deleting operator. Right? Okay, so forgetting about this for a minute. I'm going to show you the disassembly. So everyone would write this down, because if you're using the vector new, which is what this is called, then you should use the vector delete. Okay, so now let's see what that compiles to. Okay, call operator new. Now, when I step into this operator delete, you want to see that we are, let's say, alright. This is I know this is what they call the scalar deleting, alright. In order to prove it's the same function, first off, there's no vector here. I just want to delete the 1 byte. It's going to go to exactly the same spot. See, it's exactly the same operator delete that we ran into last time. Now that wouldn't be the same. It wouldn't be this one if this were an object that had constructors and destructors. Here, see? Vector deleting destructor. It's not the same thing at all. Okay. It doesn't show any source code. What it's going to do is it's going to call all the destructors on those strings, and then this is something with exception handling. But all of this is saying vector delete, vector delete, vector delete, and the reason being that if you look at PB, okay, here's the FD that would come from malloc. Right? Now there are 100 of these strings, unfortunately, too many, but here's where it ends. But a regular malloc, if these were bytes, has the FD right in front of the malloc memory. So malloc or alloc or new and all those things use the same mechanism, okay? And there's always 4 FDs surrounding the allocated block. So here should be exactly 100 single bytes worth of data. Is that 100? Can't tell how wide this is. But it should be going on with bytes. So it's perfectly fine to say this. smart pointer to byte, h bytes, say, is new byte of 300, and if I wanted to, now that I got that cast, this might actually move. Let's just say so just all of the characters up through 255. It's ambiguous. It's not that much of an advantage, I guess. It's not too bad. This should just give us all the characters up to 255. One, two, three, blah blah blah. It looks correct, right? C D C C F D 0 E F, and if I run, there's no memory leak. So as I said, that's all there is to it. Except I missed one byte. Should go to. That's up to, but not including. My time. Oh. Whoops, wrong thing. FF. No memory leaks, no crashes. Vector new, scalar delete. I don't know how to. Well, we can get to here. There. Something, there we go. There's our data with the FDs right here. And after FF, there's going to be 4 FDs on the next line. 1, 2, 3, 4. Okay. So that's that. There was one other thing I wanted to mention, and that was to do with that thing that keeps bothering me, whether or not I should delete this H handle. See, before I was declaring this here, and now I'm keeping it. Turns out that this H bitmap has use. You can use it to extract a div section or a bitmap from your just from it. You call get object on the H bitmap that you created, and if you specify the size of a div section, you get whatever a div section is. I'm not sure exactly what it is. It does, though, tell you how big this. Now this is. Let's see. I extract them with this program. Okay, now that's the bitmap one. Sorry. Oh, I don't display all of this. There's more I could print out. Where am I printing it? If there's a bitmap info header, then there's all the other stuff that comes with a bitmap info header. I should probably have if I wanted to, let's say, add one more line. Oh, what do we want? Width, height, pixels per meter. I wonder if anyone's ever used these. Well, let's just say when I look at size image. Well, width, height, I guess. Is that right? Normally this would happen on double click, but I can't double click. Let's force you to 1639, that's correct. Here's the actual DI bitmap. 1639, 24 bits per pixel. You would never guess it, but this is in fact a multiple of 11. And width, not particularly interesting. What else is in here? Anything important? Pixels per meter. Well, I wonder what it says for that. I wonder if it just takes what I gave it. Oh, that's a bit. per meter. MTR fits. And it makes no difference in terms of the zero. Good enough. You see, I've been using these magic numbers all my life because where do I set it up? Because once I saw a bitmap and these were the numbers, so I stuck to them from that day forward. And I have no idea. I don't think anyone has ever used these numbers. Pixels per meter. Who would care, for one thing? And that's going to depend on the display. But these numbers have always worked for me. The other thing to note is if I run the Process Explorer, well, I have to do it with and without, but you'll notice that it makes no difference. Trust me. User handles is always 20, or 19, or 18. These are 60-ish, and this is either 20 or 21. Now I gained a user handle that will probably go away. Or I may have missed a timer. Oh yeah, see, I lost 2 there. I probably had 2 timers going. When you create a timer, that's a handle, right? And no, but I've never created a new one. Look, if I turn them off, I gain a handle. If I turn them on, I lose a handle. But these don't cost anything. These don't seem to do anything. This doesn't seem to change. So, so I'll keep it. And now I know I can set these to 0. And there's a glitch. Yeah, what else? That's it. So you've seen the weirdo smart pointers for for aggregate types, bytes and whatnot, RGB quads as an example. Any struct that has no constructor or no destructor will not use the scalar delete. The vector delete. So those things can be used in that smart pointer thing. And instead of struggling over understanding the horrible looking syntax, you can just use it. It's just, it looks ugly, but it's quite useful. They're all over the place, and this GIF thing, really indispensable. I have no idea how to keep track of, what's malloc and what's in what list and blah 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 without it. Well, this is already too long. I have things to say. What I have a lot to say about and what's going to come up in the next one is what this unit test was really about. Is it still here? It's about these reparse points and file attributes and get long file name and get. It's weird because things. Oh, I figured out how to get a handle to a directory. None of these flags seem to matter except this. If you say backup semantics, okay, and existing, if this is a directory, you will get a handle, and then you can do that, get information by handle, and you'll find, for instance, that this directory has the same unique identifier as this one, and get long file name works on this directory, but get long file name fails on this one for some reason. And this is the real directory, and it fails. However, this does have the same unique identifier as this directory. So it's a real confusing mess. And so I'm writing this attribute, a version of this, right? And it prints out this ASH blah blah blah, but it has some extra flags like reparse point, and some of these other ones that came up, like compressed. This attribute doesn't give you compressed. I print that one. Not content index. You'll find that those junctions are not content indexed. It makes sense. They're not indexed. They're not encrypted. Wasn't compressed anyway. They have this flag. I have no idea what a sparse file is. Not temporary. No idea what that means. But directory was one of the attributes. So you can get the attributes, but you can't do like what I'm doing here. Get find file, find next file, that re-edit. Okay, well, once I figure something out about that, I'll let you know. See you.